Did you know that coastal erosion is eating away at U.S. beaches at a rate of about 1.25 meters or 49 inches per year on the East Coast, and at a rate of about 21 centimeters or 8 inches per year on average on the West Coast? Coastal erosion is a problem that costs the U.S. about $500 million annually. Lighthouses showcase this problem well. If a lighthouse is built 200 feet back from a cliff and the cliff erodes at 2 feet per year, then in 100 years the lighthouse could just topple into the ocean. Half a dozen lighthouses that I know of have been moved back from the beach to protect them from being destroyed this way. Here's something to think about. The United States is only 177,410,000 inches across as a very sober crow flies. If you divide 177,410,000 by 57, which is 49 plus 8, which is the total inches of coast eroded by both oceans every year, you get 3.1 million. In other words, if the erosion rates stay the same, in 3.1 million years, both coasts working together will consume the entire continent and meet around the Oregon-Idaho border. What happens if we extrapolate backwards in time? Check this out. The continental crust of the Earth is much thicker and less dense than the oceanic crust. A bit of the continental crust extends into the oceans. This is called the continental shelf. We can see the continental shelf in Google Earth, and we can measure from the edge of the continental shelf back to the beach. I'll take a bunch of these measurements on the East Coast and drop them into a spreadsheet. Then I'll average the measurements I took. The average is 131.8 kilometers. I'll multiply by 1,000 to get meters and then divide that number by 1.25, which is the average erosion rate according to Google at the moment. The number is 105,440 years. In other words, assuming a constant rate of erosion, we are looking at only 105,440 years since the East Coast started being eroded by the Atlantic Ocean. Let's look at the West Coast. I'll take a bunch of measurements again, average them, multiply by 1,000 to get meters instead of kilometers, divide by 21 centimeters, which is 0.21 meters, and the number comes out to 105,158.7. That's only 281 years off of the value I got for the East Coast, and I was just picking random places to measure. Some people will say that the natural state of the coast is equilibrium and not erosion. For some places this is true, at least in the present, but for most beaches this is not true. When the surf erodes a cliff, it is cutting into ancient material. This, for example, is an old sea cliff, and it's definitely not in equilibrium. The land used to extend much further out into the sea, so what does this mean for Earth's history? One important point is that the roughly 100,000 year figure I calculated assumes no catastrophes, which is wrong. There's tremendous evidence of intense geologic catastrophe in the recent past. These catastrophes would have greatly exacerbated erosion, so the real number will be much less than 100,000 years. One obvious interpretation of this data is that Pangaea split up only thousands of years ago, not millions of years ago. This is just one way to measure and constrain the age of the Earth. If it were just this one weird fact and all the other ways pointed to a very old Earth, I'd just chalk it up to an anomaly that we don't understand yet. But the truth is that most of the ways that we can independently measure and constrain the age of the Earth don't allow for billions or even millions of years.